And we are live. Let me just make sure. Can you guys hear us? Yeah, I think we're live. Well, thank you everyone for tuning in. As you can see, we have Upal, our co-founder and CTO.
Yeah, filling in for the much more charismatic Matt Foley, who had a little bit of a thing he had to take care of this afternoon. But hopefully, y'all are okay with dealing with it.
Mixed in with my own ineptitude when actually scheduling this live stream, so apologies for that. I'm Antonio, our co-founder and CEO. We are actually gonna dive right in. So this week, we announced live support for BEM. That means moving forward, our users will be able to upload video on BEM and understand semantically, extract semantic features out of it, as well as understand sort of the details in those videos.
Yeah.
A lot of what we've seen from existing users and customers is understanding and moderation of social media content, retail and e-commerce, supply chain automation.
Yeah.
So we're going to dive right in. And actually, I was thinking we could just build a couple of workflows live.
Yeah.
Really. So this demo is completely live. We haven't prepared other than the videos, which Matt has graciously made some synthetic data for us to use in these inputs of videos. We also found some YouTube shorts that we could use as inputs, but everything you'll see today is completely, let's call it improvised and completely built on the spot.
Yeah, Bill O'Reilly mode. We're doing it live.
We're doing it live. And so we're excited to dive right in. If you guys have comments, you'll see that I am sometimes moving to the left and to the right to look at our comments. If you guys have any comments whatsoever, post them. We'll try to get right to them as soon as possible. So let's actually do this. I have my computer right here. What you can see and hear is BEM's playground. So just for context, for everyone tuning in for the first time, BEM is a platform that allows you to structure unstructured data and extract and metadata about documents, video, audio, everything in between. The way that I describe it to a lot of people is we effectively replace the need for manual data entry. So if you have a business process at your company where you have people typing in invoices, we have people using BEM for loss run reports on insurance, medical claims, authorizations, benefits. You don't really want your people to spend time doing manual data entry. You want them to actually do what is highest leverage for your business. So we focus on automating the entry, automating downstream effects from that entry. So a lot of enrichment with your own data, validation with your own database data. So that's what BEM does. For the purposes of this demo, we actually just released video support. So what that means is I can actually go on BEM and start analyzing video, not just PDFs or images. So we're going to actually use for this example, I have some files here that we can use for example. So the first one we're going to be analyzing is one where you can detect from a camera feed certain OSHA violations and others. So let me actually upload this to here just so that we can see it, because I'm sharing my screen on Chrome. But you'll see that this is a video of someone is walking around on their phone, they're distracted. This was synthetically generated. I think we used VO3 or something similar.
Yeah, unfortunately, or fortunately, we don't have that many OSHA violations in the office that we can pull from. So we had to generate some.
And so what we're going to do is create a semantic analyzer that understands if any OSHA violations are being committed, any remediation, any improvements that could be made. So we're going to dive right in. The first thing you do is create a workflow in BEM. For this, I'm going to use our analyze function. Analyze supports video and documents, but focuses more from a visual perspective. If this was a document, I would probably use our transform function that focuses more on documents.
Yeah.
That's state-of-the-art, essentially like semantic extraction for documents. For this purpose, we're just going to use analyze. So let's call this OSHA violations. And I am going to use our new visual editor, by the way, which, you know, if you're just not very good at writing output like JSON schema, just like myself. I'm just not very good at it.
Or you're just annoyed by adding all the double quotes and validating the types and blah, blah, blah. We've launched something that's a little bit smoother of experience here.
Exactly. And I'm going to add a few fields. The first thing I'm going to do is I'm going to add an object called OSHA violations. I'm also going to add a array of, I did not want it there. I wanted it right at the top level. There you go. And we're going to call this sort of visual. I wanted to call it, what do you think we should extract? Something like visual aspects of the scene and the...
Yeah. Or like we could do things like number of people or like violation count, like, things
exactly.
like that. Yeah.
And then during in OSHA violations, I'm going to add a array of violations. And each array is going to be an object of the violation in question. Am I doing this right? Yes. It's going to be a description of the violation. We're going to add a description here. Any codes, if applicable. And any recommendations. So you can see how you can slowly build your own schema. We decided to do this completely unprompted. We can't fake this demo just because we want to show you what it's like to actually build something from scratch in BEM. Let me actually add here recommendations, recommendation to remediate violation. Let's run this for now. That's the beauty of BEM, is that you can just iterate on the, while testing.
Yeah.
We're going to save this right now. Now, this is a function that is fully saved. Now you can start testing it. So I'm going to drag and drop the OSHA video that we talked about before, and I'm going to run it. Now, the beauty of running this through tests is that you can iterate on it progressively.
Yeah.
So we're going to be able to see here that there's at least one OSHA violation, which is the emergency exit is blocked by a stack of pallets, which could impede evacuation in case of emergency. I actually did not realize this when I looked at the video.
Too, yeah.
I was focusing on this guy walking around with looking at the cell phone. This is a very interesting violation. Obviously, this was synthetically generated. This exit would be,
it's also blocked on the other side.
It's blocked on the other side, and that would be a very weird emergency exit. Yeah. But it's an interesting thing. Now, we could continue iterating on these, right? We could say, well, on top of OSHA violations, we also want to do another array of OSHA violations and risks, for example. So we're going to call it OSHA violations and risks. And this is going to be risks. And we're going to call it risks that could lead to violations.
Yeah.
And we're going to add similarly we can just make this honestly an array of strings.
Yeah.
And so here we're going to say description of the risk associated. That's pretty much it. So we can start kind of iterating, and now that the video is loaded, we can run it continuously. Because it's so fast, I can actually keep adding and removing more of these violations. So now that we have risks and violations, now we can see how a worker is operating a pallet jack without wearing a hard hat. That's actually something that I didn't even realize myself. We can also see that a worker is using a mobile phone while walking in a warehouse. And we can see that there is an array of risks now where you're distracted walking, leading to collisions or falls, head injury from falling objects, forklift.
The first one was what you expected, the violation, but I guess that wasn't a current or like an active violation, unlike the exit signs. So.
Exactly. Now, the cool thing about BEM is that, and we've mentioned it in our announcement, is that all of the new functionality on Analyze is completely compatible with our existing primitives. So you can actually enrich based on that. I see actually a message from Leonardo. He's asking, how was it able to detect a violation without loading OSHAs per se? That's a great question. So for this type of work, so there's a couple of things, right? The models we use under the hood, let's say you use a vision model. If it has sufficient understanding of what OSHA means and what the violations are, then you can sort of make some inferences as to what the codes are. However, in my opinion, the right way of building this is more a description of the scene that then is enriched with a source of truth of OSHA violations.
Yeah, so you can link an enrichment primitive after this, like with our workflow, like builder, actually then be able to link and then update or just sync OSHA like violations kind of actively from a catalog to that, and then that will much more discreetly define these like pieces and actually do more, let's say, like semantic matching against like the resulting like data that we pull.
Exactly. And in fact, we're about to demo this because I can enrich this data in a description of the images with a source of truth of OSHA violations. I'm going to go into collections and I'm going to create a new collection called OSHA violations. And I am going to go into the collection. And for the purposes of this demo, I'm just going to create a synthetic data set. Now, for testing, we've added the ability for our users to generate synth test data very, very quickly. But in a real production use case, you would just add all of the OSHA violations that exist. And you would have a source of truth. These collections can be hydrated via API or via the UI. So I'm going to create synthetic data, and I'm going to say collection of 50 OSHA violations with a description of each. And each also should have a code.
Yeah.
That way we can uniquely identify them. This is a way to move very, very quickly. This is meant not for production use cases, but more for like testing very quickly. As I mentioned, you would want to create a collection of your actual data. You could have, for example, a collection of millions of SKUs in your database and then filter by customer and things like that. So we're going to generate this kind of synthetic one. We have another question. So from Shiv Kumar, he's saying, can it read text from videos like license plate of cars when in motion? Yes, it can. I can actually demo it pretty quickly. Basically, we have the collection of OSHA violations. I'm not an OSHA expert, so we'll just take it for fact. And now I've added it to the collection. What we do behind the scenes is essentially RAG. So we actually create all of the vectors, all of the embeddings, store them in a vector database that we can query live. That way you and your team don't have to worry about whether it's RAG or not RAG. We just deal with it behind the scenes. We're going to give it a second so that it processes completely. But essentially what we're going to be doing is if I go back to my workflows into OSHA violations, I can add a new node called enrich. So Shiv Kumar, for example, for the question that you were asking, not only it can read text from license plates because we're using a vision model, it could also enrich and match with an existing collection of trucks, cars, vehicles. So it could be a great way to automate, for example, the ins and outs of a warehouse or a secure place. I'm going to call this OSHA database. And you'll see that it allows us to add a series of enrichment steps. I'm going to tell it to go through the OSHA violations collection using the source field in the description of the violation. And I'm going to call this field enriched. Let's try it out. Am I doing this right? Semantic description. Oh, there you go. That's what I wanted to do. So I'm going to save this and I'm going to run it again. I'm going to drag and drop the video just like I did earlier. And let's try this again. So now you'll see two steps instead of one. The first step is, hey, This is the analysis just like before.
Yeah.
We have a pallet jack being operated without a hard hat. We have a mobile phone. And then you have the enrichment.
Mhm.
So you can actually start creating a very good, so you can see here how we have a head protection enrichment
Yeah.
due to failure to use a hard hat. You can get very fine-grained with the way that you enrich it.
Exactly.
And so, Leonardo, to answer your question, instead of relying on the model to determine what the code is, we rather people and customers just use the vision models themselves to extract a description of the scenes and the imagery, and then for enrichment to be more grounded, so to speak.
Yeah, like the single step like allows you to pull like a ton of context around that, but like to make it context aware, it's like great to kind of link that subsequent step. So not just for, you know, better like search and more like kind of structured capabilities, but also that you can kind of dig in step by step and tune individual pieces like over time. Like for example, with the analyze step, you might want to use our fine tuning capabilities to actually be able to like steer and use certain verbiage that you want over like certain fields, but then also not necessarily disrupt like, oh, but these codes are like very fixed. We want to keep these in line with national regulations and like actually link these back to like an overarching kind of catalog there, and kind of gives you an easier step-by-step process to, yeah, get to the end workflow you desire here.
Exactly. Now, the beauty of this is we did a strictly semantic search earlier. You can choose what kind of search you do. For something like matching license plates, I would probably do what we call an exact search or a hybrid search. Hybrid allows you to basically tell the model, use a weighted average of both the distance in the text, so how similar is the text, but also semantic search. And in fact, if I use a hybrid one and I retest, I'll probably get slightly different results because I'm using also the text involved in the description of the risks and the violations. And you'll see that we go through the first step, it runs through the second. So now we have, again, fall protection failure and head protection. My guess, it probably has some weight, the fact that now we have words like head, like hard hat, and whatnot.
Exactly.
The other demo that we wanted to run through very quickly is actually one that is kind of interesting. We've done a video, we posted a video on our website about how to build a retail AI agent. I won't go through that again. I will go through one that is kind of fun, that is a trail camera. So our CS engineer, Matt, created a synthetic video that is essentially from a trail camera. You can see here, I'm going to upload it so that we can all see it. It's essentially a trail camera with like a few animals. Obviously, you can tell that it's synthetically generated, but I think it's a pretty good approximation what you could find in a trail camera. Now, the cool thing about this is that I can create very easily an analyze function that extracts what are the animals and circumstances. And so this is an example of something you could do with CCTV. You could have a RMTP sort of feed and then chunk it into, let's say, 30-second increments and send it to them for continuous live stream understanding of everything coming in. And it's great for security applications and whatnot. So for this purpose, for the purpose of this one, I'm just going to focus on the animals for now. So I'm going to create an object called, actually, I'm going to create an array called animals. And inside of it, each member of the array is going to be an animal with the name of the animal. I'm going to add a description so our models understand it really well, as a description, visual description. And let's just run that. And I did this in 5 seconds, right? I'm going to run this super quick. And you'll see that it goes pretty quickly. I mean, it's also a really short video, but it detects that we have a deer and a fox. Now, I know obviously this is a really interesting example because it's just animals, but again, with the similarly, I can do downstream effects from this transformation. I could say, well, I want to keep a collection of animals. So I have it right here. And I want to add I want to make sure that I keep track of all these animals. So I'm just going to say collection of 10 animals include at least a fox and deer. Each should have its own UUID. You could imagine this for, I mean, we're obviously using animals, but you could use any kind of example.
Yeah.
I'm going to add this to the collection. And then while it processes, which is strictly asynchronous, I can go back to the workflow that I created and actually add an enrichment process that I'm going to call the zoo. And with a really simple step, which is go through our animals collection, go through the name of the animal, and try to match it with a enriched from DB, sort of like try to inject it in the collection.
Mm.
I'm going to use, for this, it would probably make sense to actually do exact search.
Yeah.
So we can look at what that looks like. And I'm going to include distance as well. And I'm going to add, just so that we can see multiple results.
Mm.
And I just drag and drop the file. Let me add the trail camera file and just run it. So now you'll see two steps, right? One step is the initial extraction of the deer with antlers, and then the second one is the enrichment with the actual deer from our database with its own UUID. We never thought of BEM as a zoo security system, but it could be very interesting to sell
like,
to zoos.
You got a feed in your backyard. You want to know what critters are popping.
Exactly.
Yeah.
Now, the cool thing is, this is obviously a enrichment that is done through Exact. I'm sure that if we get a hybrid, we will get very different results. If we enriched it with just the description, for example, right, and then I made it hybrid and I run it again, you'll see that we get slightly different results and potentially sometimes things that are more semantic in nature. I think there's very little variability between the entropy isn't as high, so you're not going to have
we don't
as
have
much
that many
crazy results.
Here. Yeah.
But it's a really interesting way to essentially, you'll see that we get, for example, deer and beaver.
Yeah.
And in this one, so this is an example of where like the first enriched result for fox is actually deer. This would be just wrong.
Yeah.
The main reason being I use the description in a hybrid way. You'll see that I use hybrid. For this type of use case, you should just use exact search. The last use case that we wanted to show before we wrap up is retail. So we've talked about retail ad nauseum. We actually have a demo that we built for our website called Demo the Product Detector. It essentially detects products in any kind of video. I'm going to upload these two user-generated videos on YouTube of someone who is just buying goods around a grocery store. And we've seen users actually explore this feature as a way to add a level of retail intelligence and e-commerce intelligence, as well as competitive landscape. It's a great way to actually extract very clear data. And so, for example, for this is a Mummify purchasing stuff in Walmart, and you can see how she has better goods chips. She has overall positive sentiment with the stock condition. Is the shelf at eye level? Mission tortilla chips. But also, if you look at the next step, it matched it with the actual Better Goods product within our product catalog. So it's a great way to actually create very quick production-ready pipelines for retail intelligence.
Exactly.
You can validate planograms and actually achieve compliance of planograms and product positioning very quickly. You can use this for inventory tracking and whatnot. We're excited for you to try this. This was meant to be more of a live build. Next week, we are making some announcements that are more on the infrastructure level, which is how can you deploy BEM in a secure environment in a way that it never leaves to the public internet. So we're launching some pretty cool stuff. And next Thursday, we will be joined by our head of platform engineering, Gary. So tune in next week. We'll announce it shortly.
Yeah, and please jump into the platform, give the video analysis of all the enrichment a try, and let us know what you think.
Yeah, sign up, try it out, and give us feedback. Thanks, guys.
Thanks, everyone.